All right, so we're going to take a look at the free response question that was part of the homework for AP review number 1. All right, mixes in a few ideas, some around continuity, some around derivatives, some around integrals. All right, let's take a look at the problem. Let f be a function defined by this piecewise function right here. For x is less than or equal to 0, x is greater than 0 down here. All right, so let's take a look for part A. For part A, show that f is continuous at x equals 0. Okay, show something's continuous. We know we have 3 criteria. We need to show that the limit exists. So we can say the limit as x approaches 0 from the left of, let's see, the left-hand side of 0 is going to be 1 minus 2 sine of x, right? 1 minus 2 sine of x. So as x approaches 0, so x is approaching 0, sine of 0 is 0, so this is 1. What do I know about the limit then as x approaches 0 from the right? Because I know I got to check both of those things. The right-hand side of x is 0 will follow e to the negative 4x. I got to check both of these things and make sure that the limits are the same. So as x approaches 0, that'd be e to the 0, which will give us 1. So I now know that the limit as x approaches 0 from the left of f of x equals the limit as x approaches 0 from the right of f of x, which means therefore the limit as x approaches 0, I guess, and these things both equal 1, right? Therefore, the limit as x approaches 0 of f of x exists and is 1. All right, so here's the first criteria that we need to check for continuity. Second criteria we need to check is we need to make sure that there is a point there, so we need to make sure that f of 1 exists. F of 0 exists. F of 0. When x is 0, we use this top branch of the function. When x is 0, that'd be 1 minus 2 sine of 0, right? Which will give us 1. So f of 0 is 1, okay? So we know the limit exists, the point exists, and in step 3, we need to state that the limit then as x approaches 0 of f of x equals f of 0, which is 1. And we can say, therefore, f is continuous at x equals 0. There we go. You got to state the limits like we did up here. Got to state our limits. They're both 1, so the limit exists. The point f of 0 is 1. And the limit as x approaches 0 equals f of 0, which is 1. Therefore, f is continuous at x equals 0. Those 2 points for this entire analysis. You had to get everything here for the 2 points. All right, let's move on to part B. Part B says, all right, for x is not 0, let's express f prime as a piecewise defined function. So we want the derivative of this. F is piecewise, so the derivative will be piecewise, but it says don't include x equals 0. All right, this shouldn't be too bad. So f prime of x is going to be equal to, what's the derivative of 1 minus 2 sine of x? Well, the derivative of 1 is 0. Derivative of negative 2 sine of x will be negative 2 cosine of x. And this is going to be for x is less than 0. I got rid of the equal to sign because we're not going to include when x equals 0. It says in the problem, but also we'll have a non-differentiable element there if you wanted to investigate that. So I'm taking off the equal sign because they don't include when x is 0. All right. There's that. Let's take the derivative of the denominator. Here it looks like we will need the chain rule. It's e to the negative 4x. So e to the whatever is e to the whatever times the derivative of the inside here, which is negative 4. So negative 4e to the negative 4x. 4x is greater than 0. So there we go. We express f prime as a piecewise defined function. Find the value of x for which f prime, the derivative is negative 3. Well, let's see. Is negative 2 cosine of x ever going to be negative 3? Is there a place where that would happen? No, there's not. And if we want to, we can say, well, how do we know that? Well, solving this equation, we get cosine of x would be equal to 3/2. And the cosine value, its range is -1 to 1. 3/2 is outside of that range. There's no way that this can happen. So that part's not useful for me, setting this part of the derivative equal to -3. Let me try the next part. When would negative e to the -4x be equal to -3? Let's see, we can solve this. E to the -4x would be equal to 3/4. I need to get to the exponent, so I need to take the natural log of both sides. So that'd be -4x. Take the natural log of both sides. We'll get rid of the e, but be the natural log of 3/4 over here. So that means x would be -1/4 natural log of 3/4. Right, and so there's my value. Find the value of x for which f prime of x equals -3. So I can say at x equals -1/4 natural log of 3/4, f prime of x equals -3. All right. So this part was 2 points. Oh, sorry, 3 points. 2 points for getting your piecewise function correct. You got to get all these symbols in here, getting your piecewise function correct. If you didn't write 4, that's okay. You put a comma or something like that to indicate the domain parts there. But 2 points for your piecewise function. All right. And then 1 point for your value of x down here. All right, let's look at part C. Find the average value of f on the interval -1 to 4. Okay, so average value, we have to remember a formula, 1 over b minus a times the integral from a to b of the function or the thing we're trying to average. That's what we want. So this would be equal to 1/2 -1 to 1 of f of x dx. That's what we're looking for here in the end. Well, the half is easy to take care of. We just need to be able to determine this integral here. That's going to be where our work is. So let's see. The integral from -1 to 1 of f of x dx runs into some problems because this is a piecewise function. So -1 has to do, -1 to 0 has to do with the top branch. 0 to 1 has to do with the bottom branch. But integrals we can break up. So let's say this is the integral from, oh, there should be a negative down here. Let's say it's the integral from -1 to 0 of the part 1 minus 2 sine of x. And then we would add on to that the integral from 0 to 1, of the bottom branch, because that takes over when x is greater than 0. So e to the -4x dx. We have to evaluate this stuff here. Okay, so we can do that. And the antiderivative of 1 minus 2 sine of x. The antiderivative of that would be x, the antiderivative of 1 is x, minus antiderivative of 2 sine, so I need the antiderivative of sine, which is negative cosine. So this will become plus 2 cosine of x. Remember, you can always check your work by taking the derivative. Derivative of x is 1, derivative of 2 cosine of x is -2 sine of x. And that's going to be evaluated from -1 to 0. Plus, I need to do the same thing over here. Antiderivative of e to the -4x. You could do a u substitution here if you want. U would be -4x. Du dx would be -4. And so on. You'd have to change your endpoints. When x is 0, u would be 0. When x is 1, u would be -4. You can go through that whole process. But I encourage you to use our fast u substitution that we have called it this year. And what is the antiderivative of e to the -4x? Well, the antiderivative of e to the something is e to the something. And then instead of multiplying by the derivative of the inside, we would divide by the derivative of the inside. You could also do your u substitution if you wanted to. This would be value from 0 to 1. Okay, so what does this give us? We don't have to simplify stuff, we just got to kind of get our answer here. So this would be, when I plug in 0, it'd be 0 plus 2 cosine of 0. 2 cosine of 0. Cosine of 0 is 1, so that's 2 minus what I get when I plug in negative 1. So that'd be negative 1 plus 2 cosine of negative 1. And then I would add plus what I get when I plug in 1 up here. So that'd be e to the negative 4 divided by negative 4. And I plug in 0. And subtract what I get when I plug in 0. So that'd be e to the 0. That's 1 over negative 4. So this is the value of my integral. You don't actually have to do any more simplifying than this. In fact, I would encourage you just to leave it here. This is the integral part of this. Now I need to find 1/2 of that. So all I have to say then is half of the integral from negative 1 to 1 of f of x dx. So the average value then would be half times the quantity, 2. I want to distribute some of these things here. 2 plus 1 minus 2 cosine of negative 1 plus e to the negative 4 over negative 4. That's a minus a negative, so I can say plus 1 over 4, whatever all that is. And if you felt like taking the time to sort of boil all that stuff down, you are welcome to, but I would recommend against it because it's too easy to make some sort of small mistake or something in there and accidentally, get a point off because you simplified incorrectly even though you did all the math correctly. So I'd actually just leave it like this as the final answer. If you wanted to simplify down, the closest you could get would be 13/8 minus cosine of 1, negative 1, that would never go away, minus 1/8 e to the negative 4. After getting some common denominators and things like that, that would be where you would get everything down to. However, like I said, my recommendation, just stop here, half times the quantity that you worked out from your integrals. All right. Hopefully that helps you get a leg into this FRQ. Please make sure you grade yourself, make your corrections, and fill out the score report. The score report will also include some questions about how you did on the multiple choice problems. You can check your answers on my PDF. All right. Talk to you later. Bye. Oh, I should say how this one is scored, shouldn't I? It's 1 point. 1 point if you use the integral of negative 1 to 0 of 1 minus 2 sine of x dx plus the integral from 0 to 1 of e to negative 4x. It's 1 point for writing that out. 2 points for both your antidotors. You have to get both antidotors correct, but it's 2 points for if you get both of them. And then 1 point for your final answer down here. Okay. All right. Fill out the score report. Talk to you later.